Lesson 11.4, we're going to find numbers when the percent is known. Now, this follows right on the heels of 11.3, where in 11.3 we found the percentages. We knew our numbers, and we wanted to know what percent. In this case, we have the percent. We want to know what number do we have? What is our quantity? Now, in this particular case, just like 11.3, we're going to convert the statement into an equation, and we're going to solve the equation. All right, so I'm going to go ahead and jump right into it here. All right, I guess I have my writing tool on. 42, well, that's just a number, so I'm just going to write down. Is shorthand for is equal to, so 5%. Now, we'll want that as a decimal, which is 0.05. As you recall, of is multiplication. And then what number? Well, that is an unknown quantity. I will go ahead and use n to represent that in this particular case. Again, you'll notice here I have myself a little equation. If you want to simplify that equation a little bit, we know in our mathematical, our algebraic terms and so on, we oftentimes leave out multiplication signs. Those are implied when we leave no space. And then we go ahead and solve our equation, in this case, by dividing both sides by 5/100ths. All right, so dividing both sides by 5/100ths, my 5/100ths here reduced down to ones. So I've got my 1 in there. And then 42 divided by 0.05 or 5/100ths is 840. So my solution in this case is 840. So 42 is 5% of 840. So if you ever want to know what 5% of 840 is, it's 42. So translate into an equation and then solve your equation. And let's go ahead and go to the next one. So 60 is equal to, is equal to, there we go, the equal to symbol I use. 12% as a decimal is 0.12 or 12/100ths. Again, of is multiply, and what number? I will once again use an n. Now in this particular case, I'm going to go ahead and skip the simpler. Again, we could get rid of this multiplication sign. I'm just going to go ahead and go right to we undo multiplication with division. So I'm going to divide both sides of my little equation here by 12/100ths. And my 12s reduce themselves down. And 60 divided by 0.12 or 12/100ths is 500. 500. So 60 is 12% of 500. All right, off we go. Again, following on the heels of 11.3, and when we were finding percentages, in these word problems, so to speak, we're going to find a number, and if we can notice the key phrase and pull that out, a lot of times that key phrase will tell us what to do. So in a science lab, a sample of a compound contains 14.5 grams of magnesium. If 72% of the sample is magnesium, find the number of grams the entire sample weighs. Now, if you go into there and you pull out what the key phrase, the key statement, it's the 72.5% of the sample of magnesium. This is basically telling us what to do. Okay? So if we go ahead and translate, I'm going to go ahead and translate right now. 72.5%. Oh, need to do that as a decimal. Let's go ahead and do that correctly. 0.725 times the sample of magnesium in this particular case. And so now, do I know what the sample of magnesium is? Well, if I go back up here, in a science lab, a sample of a compound contains 14.5 grams of magnesium. So I do know my value of that, 14.5. So in this particular problem, again, we know the percentage. And the nice part about this particular key phrase is we don't actually have any solving to do. It's not really an equation. We just have two numbers here that it's telling us. Take the 72.5% and multiply by whatever our size of magnesium is. In this case, 14.5 grams. So I'm punching this into a calculator as I talk, and which you can do the same. So 10.5125, and in this particular case we're talking grams. So in this particular case, 72% of the entire sample is 10.5125. All right, let's keep rolling. The king cobra can reach a length of 18 feet. This is only about 60% of the length of the largest reticulated python. Find the length of the largest reticulated python. And again, if we go in here to key phrases, it's right here. This is only about 60% of the length of the reticulated python. And notice the this part, this is referring to the 18. So basically we're saying 18 is only, and if I'm not going to worry about pulling out my key phrase, but I had it all set and ready to go here. In this case I highlighted it. So what we're saying here is 18, because you're probably not going to have a little key phrase thing to pull out, equals, there's my is, only about 60%. I'm going to go ahead and change that to a decimal right now, 0.60, of, let's multiply, the length of the reticulated python. Okay, I'm going to use P to stand for the length of the reticulated python, because our job here is to find the length of the reticulated python. So you'll notice here, once again, I've got an equation. If I go ahead and solve my equation, in this case I will be dividing both sides by 0.6 or 60 hundredths, which actually I could go without the zeros if I wanted to. But if I divide both sides, and again my 60s will reduce themselves out, and so I'll be left with P over here on the right. 18 divided by 6/10 or 60 hundredths is 30. Oh, not 33, sorry, let me fix that. 30. So, find the length of the largest reticulated python. Well, the largest length is 30 feet. Gosh, that is a big, big snake. So, all right. Kerekules, I don't know how to pronounce that, so I'm just going to say Megalodon. Megalodon is a shark, a really, really big shark, a prehistoric shark. Had teeth as large as 7.25 inches along an edge. This is about 240% of the maximum length of the teeth of a modern great white shark. To the nearest inch, find the maximum length of the teeth of a great white shark. And again, key phrase right here. This is about 240% of the length, and then all the way down here to shark. Okay, so if we can find that thing, and remember, in this case, this, if we refer ourselves back, this is discussing this 7.25 inches. So I'm going to go ahead and I'm going to start translating this key phrase. So 7.25 inches is equal to about 240%, which is 2.40 as a decimal, of, multiply, the maximum length of the teeth of a modern great white shark. Well, I'm going to go ahead and use W in this case to represent my length of the teeth of a great white shark. And that's one of the nice parts about variables, and why we use variables, is I was able to write this whole sentence, this the 240% of all the way to shark, in one word. Well, okay, in 3, 4, 5 characters or so. And now I can go ahead and solve said equation. In this case, we're going to be dividing both sides by 2 and 40 hundredths. Okay, so my 2.4 and my 2.4 reduce themselves out. And I will use my calculator here and divide by 2.4, which, and we are to the nearest inch. Okay, notice to the nearest inch. In this particular case, it's 3.02, which we will round to the nearest inch, 3 inches. So the maximum length of a modern great white shark along the edges is approximately 3 inches, where the Megalodon, 7.25 inches. That is a big, big shark. So, all right, practice time for you. Any questions? Obviously, I'm here to help. Come see me when those arise. Good luck.